Okay, this assignment here can be a butt kicker. Tomorrow you get an 8-problem worksheet. You got to find 4 of them you think you can get. Okay, a contractor is paid $95,000 for the construction of a building. The contractor's expenses are $81,700 for expenses. What percent of profit is made on the job? Now, this is how you would set up profit. Because there's going to be a couple of those tomorrow maybe you can get if you follow this one. 100%. Now, you're finding the percent profit. Now, for the base and the part on profit, the base is how much money you are paid. The profit is not given in the problem, okay? So how much money was I paid? I was paid $95,000. To find the part, okay, and the part is the profit you make. By the way, the part is where you'll want to write that down. The part is the profit, the base is how much you were paid total. Now, to find the part that was profit, you have to take how much you were paid and minus the expenses, $81,700. $13,300. Now I can cross multiply and divide and find what percent of the part was profit. So 100, you cross multiply and divide, it's 14, so 14%. Okay, next one. A lab technician usually prepares 245 milliliters of a solution. The technician prepares a new solution that is 35.75% more than usually prepared. How many milliliters of a new solution are prepared? Now, you're going to be careful with your percent here. When you see that word more, that means you don't just put the percent. You got to take 100% plus 100 plus 34.75 and then put the percent. So that's 134.75, and that's the percent we're going to use. Now, base and part. Now, the base is identical. When you have more than, it's more than what? Okay? It's more than usually prepared. So, usual is the base. So, how much is usual prepared? You're usually doing 245. So, 245 is the base. And then we cross multiply and divide. 134.75 times 245 divided by 100. 330. Don't mess around with that decimal nonsense here. That's 330 milliliters. Okay, next one. A printer has 782 reams of paper in stock at the beginning of the month. At the end of 2 weeks, 60% of the reams in stock are used. How many reams are remaining after 2 weeks? Now, this one, again, you're not going to use the 60 because you need to find the remaining amount. That's a key word. So, if 60% were used, what percent remains? I'd take 100 minus 60, and that'd be 40%. Now, base part says of the reams in stock. Stop at R and just what the base is how many you have in stock. So how many do I have in stock? You know that. You know there's 782 reams of paper in stock. 782 is your base, and the part you're finding is how many reams are remaining. So you take 40 times 782 divided by 100. It's 313 reams. So those ones people might have a shot at. So again, the profit especially, okay, make sure you took good notes on that. There's a couple on there you could be able to get. Okay, we're going to come back to the welder problem. That's one of the tougher ones, okay? This is one of the tougher ones. This is one of the tougher ones, and we're going to do that. We're going to come back to that page, okay? Those are tough ones. Okay, another profit problem. A company makes a profit of $50,000. This is 10% more than the profit from last year. Find the profit from last year. So they give me the percent, but it says more than. So I want to take 100 and add 10%. That's 110%. More than what? More than the profit from last year. So when I set up my base, the base is last year. And the part is this year. The part would be this year. Base is last year, part is this year. Okay, now, that doesn't say it was last year, okay, 50,000. So that is not my base. I got to find the base because they're asking me to find the profit from last year. $50,000 is the part because that's this year. So I take 100 times 50,000 divided by 110. 45,455, okay? So if you're going to round, make sure you do that. So $45,455. It'll have the same label as that one. Okay, I have read 480 pages of a book to read. After reading 200 pages, what percent of the book remains to be read? So you take 100%. Now you don't have your percent. So you got part and base. Now in this problem, the base is how many total pages there were in the whole book. Okay? But I am not going to put and I don't know that. Okay, I've read 200. That's not how many are in the whole book. The base is the total pages in the book. So I don't use 200. Okay. So what I'm going to do is I'm going to put 200 in the part. Okay. And then X right there. Or no. There's 480. I do know my base. It's 480. My bad. So I take 200 times 100 divided by 480. 42%. Now, you got to be careful. That is not the final answer. That is how many you've read. The 200 pages, how many are read. So you've read 42% of the book. Okay, how much do you have? What percent do you have left to read? Well, I could take 100% minus 42%, and that would be 58%. So those remaining amounts you got to watch, okay? You're going to have to do a subtraction somewhere. Okay, next one. A recipe is composed of 70% flour, 10% baking soda, 8% sugar, 4% eggs, and some milk. Find the number of pounds of milk needed to make 45 pounds of the recipe. Okay, so we got the same idea going on, okay, or with that. Now you get all these percents. Only one is needed for this, okay? So you get your percent over 100%. You're like, what do I put for percent? I got all of them. You're not going to put any of them, okay? You need to find the percent that is milk. That's what you're being asked to find, how much milk is needed. So you take 100 and then subtract all of the percents you know. Minus 70, minus 10, minus 8, minus 4. That's 8. So 8%. So part base. Again, the base here in the recipe, when you're dealing with recipes, the base is how much total that you need. And the part is what it's asking for, the milk. The part, the 8% is the part that's milk. Okay, what appears to me, the 45 pounds is the total. Okay, so 45 is that. And now I can cross multiply and divide. 8 times 45 divided by 100. 3.6. 3.6 is a good enough amount. Okay, so it'd be 3.6 pounds of milk is how much you need. You need 8% milk. Okay, you got 45 total. That total is your base in a recipe. Okay, this one. Two machines are constructing parts. One machine with a capacity of producing 450 parts per hour is operating at 60% of its capacity. Another machine with a capacity of producing 550 parts per hour is operating at 70% of its capacity. Find the total number of parts produced from the site when the machine operates for 5 hours. Now you got two machines, so you're going to make two proportions here. Now, you're not going to add or subtract on the percentages. You're going to use the percents given, 60%. And over here, you're going to use 70%. Okay, so you got part and base. Part and base. Now read after percent of its capacity. So the capacity is your base on both of these. So what's the capacity of the first one? It says it can produce 450. So 450 is the capacity on the first one. And I'm trying to find the parts they can actually. That means if it's running at 100%, they can produce 450 parts. Over here, if it's 100%, okay, they can produce 550. X. Okay, now 60 times 450 divided by 100. It's 270. Now read, that's 450 is labeled as parts per hour, so 270 is parts per hour. Keep that in mind. Okay, so 70 times 550 divided by 100. 385 parts per hour. Okay. Well, the thing is, I have to find how many were produced in 5 hours, okay? So it'd be 270 times how many hours I have, which is 5. So 270 times 5, and then I go take the 385 times 5. $1,350. $1,925. So in 5 hours, he can produce that many parts, and he can produce that many parts. Now, the question's asking me, find the total number of parts, so that means I would add those two. So 1350 times 1925, and I got 3,275. Okay, now the next one. Manufacturers need to prepare 20% solution of we're going to come back to that one. That one's a tougher one. Okay. A contractor received $20,320 for construction. The total expenses were $16,500. What percent received was profit? We did a problem just like this earlier. Okay. You don't have the percent. Now, again, the profit. The base is how much you were paid. The part is how much profit of the money was profit. Okay, well, you were paid $20,230. To find the profit, you take the amount you were paid minus the expenses, because some of that money you're paid is just you paying for your expenses to do the job for these people. The difference is the profit. $20,320 or it's $20,230 by 16,500, 3,730. That's your profit. Now find what percent that is. 20,320, or sorry, 100 times 3730 divided by 20,230. 18%. Okay, next one. Cement is 6.5 inches thick when first poured. The thickness then increases by 2.25% when hardening. What's the thickness after the hardening? Okay, now it says increase, so obviously I'm going to want to add 2.100% plus 2.25. That's 102.25. Okay, now you got to think about your part and your base. Now the base again, you know that one problem I did with where the base was last year and the part was this year? This is going to be, the base is going to be before, okay, and then after. After, before. Okay, when it says it was first poured, well, that's a before. So 6.5 is the base, and then I have to find the after. So I'm finding the part. So I go 102.25 times 6.5 divided by 100. So it'd be 6.6. Don't just put 6, just put 6.6 so it looks better. Okay, now I'm going to go after do some of the harder ones. I'm not doing that bottom one regardless, okay? A welder estimates that 125 meters of a channel iron are required for a job. Channel iron is ordered, including an additional 20% of the estimated job. Allowance for scrap and waste. 175 meters of channel iron are used for the job. The amount is what percent more than what was estimated? Okay, so the first thing I start with, okay, additional 20. So it would be 100 plus 20, which would be 120%, instead of just putting 20%. Okay, now base and part. And I know that's kind of hard to identify. Okay, 20% of what? Of the estimated job. So the base must be the estimated job. Okay, so I think the estimated job is 125. Okay, I'm going to find the part with the scrap metal. Okay, so I'd go 120 times 125 divided by 100. Okay, that's going to be 150 meters, because you use the 125 plus your scrap metal amounts to 150. However, the actual job itself, I need another proportion. The actual job itself was 175, okay? And that's including the scrap metal, okay? That's including the scrap metal. And you got to find what percent more that is. So what I do here is I transition the 150, and that's going to be my base now, and then the actual amount, 175, goes here. So you take 100 times 175 divided by 150. That's going to be 117. Now, what percent more? If you go from 100 to 117, what percent more did you go up? You went 17, okay? 117 minus 100 is 17%. Okay, the day shift of a manufacturing firm produces a 6% defective rate of 1,638 pieces. The night shift produces a 4.5% defective rate of 1,454 pieces. How many more acceptable pieces are produced by the day shift than the night shift? So we're going to make two separate proportions because I got a day shift and a night shift. Day and night. Okay. Now, we're going to adjust the percent because that's the defective. That's how many things they make that are crappy. Acceptable means how many they make are good. So I want to adjust my percent, and I want to say, okay, 6% were crappy. That means 100 minus 6, 94% were good. Okay? And the same here. 4.5% were crappy. The rest were good. So 100 minus 4.5% is 95.5%. Okay, and then base and part. Okay, now, because you have the number right after of, you have your base right there. Same as up here. Okay, so 1,638 is my base, and 1,454. That's how many total. The base is usually your total. Okay, trying to find the part that was acceptable. So 94 times 1,638 divided by 100, 1,540. That's how many good parts they had. So 95 ABC1, ABC2 times 1,454 divided by 100, 1,389. Now it says how many more acceptable pieces did the day do than the night. So that means I have to subtract those. I need to take 1,540 minus 1,389. And that's going to be 151. Okay. parts. Okay, next one's a little bit tough. A resistor is rated at 2,500 ohms with a tolerance of, could be, that plus negative means it could be 6% more than that or 6% less. Tolerance is the amount of variation allowed for a given quantity. The resistor is checked and found to have an actual resistance of 2,320 ohms. By how many ohms is a resistor below the acceptable resistance low limit? Now, we're also going to adjust our percent. Now, they want to know how many below it was, so I'm going to take 100% minus 6. If it was above, I'd add 6, but they want to know below, so I'm minus 6, 94%. Okay, now you got your base, you got your part. Now with tolerance, the base is what it's supposed to be rated at. Okay, it's rated at 2,500. Okay, so it's 6% below, which is 94%. Let's figure out what that's supposed to be. So 2,350. So the lowest it can be is 2,350. But it's below that. The actual resistance is 2,320. So that's illegal. You got to figure out how much below that is. So what I do is I take that 2,350 and minus 2,320. That's going to be 30. Okay? 30 ohms. Okay, and then last but not least, manufacturers need to prepare a 20% solution of antifreeze. If 500 milliliters of water are used in the solution, how many milliliters of antifreeze? When you pour antifreeze, you got 20% water, and then the rest of the 100% is 20% antifreeze, and then the rest of it's water. So that'd be 80% water. Okay. Okay. Well, the first thing you're going to do is you got a little problem here. Okay. 500 milliliters of water are used in the solution. How many milliliters of antifreeze? Okay. Problem is it says 20% antifreeze, but the 500 milliliters is with the water. Okay. So again, we're going to want to adjust the percent and first figure out how many there are total. Okay. And the way to do that is adjust that because, again, this is just going to be for water here. So there'd be 80% water. Okay, now base and part. Now when you're talking about a solution, the base is how many total you have, and then the part here is just the part that's water. Well, how much water we don't know how much we have total. We do know how much water we have. We have 500 water. So I take 100 times 500 divided by 80. There's 625 total, okay? Now, you're good to go to find the antifreeze. So you got 625 total, and of that amount, 500 of it's water. So that means the remaining amount's the antifreeze. So I subtract 500, so it'd be 125 grams of antifreeze. So again, I had to, in the solution, again, the percent didn't match what the value was. So I just say, okay, so 500 accounts for 80%. So 80%, 500. That's 625. Okay, cross it and you're good.